Hi everyone, so in this video clip we are going to be talking about ions. What are they and how they're formed? So let's get started. Ions are a charged atom. Now what we need to remember is that on the periodic table all our elements are in neutral form. So that means on the periodic table all our elements have the same number of electrons to protons. So this means that if we're talking about, for instance, carbon would have 6 protons and 6 electrons. So making the overall net charge on any element on the periodic table 0. So it makes it neutral. Now, when I have an ion, my atom is charged. So meaning that it will have an overall charge of either being positive or negative. And this is due to the fact when atoms either lose or gain electrons. Now, we need to remember that in our atom, our protons are found in the nucleus. And our protons are the particle that gives the identity to the element. So carbon is carbon because it has 6 protons. Oxygen is oxygen because it has 8 protons. Whereas the electrons, they're found orbiting around the nucleus. So orbiting around nucleus. Now the number of protons can never change, whereas the number of electrons can change. And when an atom gains or loses electrons, this causes its overall charge to change. And they're doing this to get a full valence shell. And that has to do with something called the Octet Rule. And it has to do with the noble gases. The noble gases are never found in compounds because our noble gases, right, they're found in group 8. And remember, the group an element is found in is equal to the number of valence electrons. So because our noble gases are found in group 8, they have 8 valence electrons. So we're going to take a look at some of our noble gases. So what we have right here, we have our sketch of our periodic table, and the column that is shaded in is group 8. Remember, our columns are our groups. So this column right here is group 1, our alkali metals having 1 valence electron. The column next to it is group 2, having 2 valence electrons, our alkaline earth metals. The column next to that, group 3, 3 valence electrons, and so on and so forth till we get to group 8. Now, if we're looking at our Bohr-Rutherford models of some of our elements in group 8, so what we have here, we have neon, we have argon. Now, we can tell based on its electron configuration that it has full shells. That the first shell is completely filled with 2, the second shell, in this case neon's only shell, second valence shell, is also filled with 8 electrons, argon 2, 8, and 8. So when I have 8 electrons on that last shell, so on my valence shell, it basically is an extremely stable electron configuration. And that's the reason why our noble gases don't form compounds, because they already have this stable electron configuration. Now, if we look at hydrogen, sorry, not hydrogen, if we look at helium, helium has also a full shell because helium has only 1 shell with 2 electrons in it. And this is also full. So this is where we have this concept of our octet rule, that all of our atoms wish to get to a similar electron configuration as their nearest noble gases. And the exception to that would be our first three elements after helium, lithium, beryllium, and boron, and that they will basically try to get the same electron configuration as helium. And what this means is that the atoms, when they're trying to get that same electron configuration, they're trying to basically emulate the noble gases in the sense that they have 8 electrons on that last shell. So when you have elements that are gaining or losing electrons, it's for the purpose of having full last shells. So if we're looking at right here, our octet rule, elements are gaining or losing electrons on their valence shell to have the same configuration as our nearest noble gas. So basically the same configuration as elements in group 8. So whether it be neon, whether it be argon, whether it be krypton, so on and so forth. The exception to the octet rule, which would be the duet rule, only really applies to the three elements after helium. So lithium, beryllium, and boron. Lithium having an atomic number of 3 protons, beryllium having an atomic number of 4 protons, and boron having an atomic number of 5 protons. And in this case, they're basically going to be losing electrons, so they end up having the same configuration as helium. So 2 valence electrons. So an atom that loses electrons is ultimately going to become a positively charged ion, because we need to remember protons have a positive charge. So protons are positive. Electrons are negative. So if I am losing electrons, I am becoming more and more positive. And this happens to elements in groups 1, 2, and 3. So let's look at an example of an element that loses electrons to get the same electron configuration as its nearest noble gas. So sodium. So if we're looking at neutral sodium, so sodium that we find on the periodic table, it has 11 protons and 11 electrons. 2 electrons on our first shell, 8 electrons on our second shell, and 1 electron on its third shell. Now, sodium wants to obtain the same configuration of its nearest noble gas. So the nearest noble gas to sodium would be neon. And neon has 10 total electrons. So that means this electron has to go. So to get rid of this electron for a full outer, to have a full outer shell. So the electron is going, and as the electron goes, that shell completely disappears. And now if I'm looking at my outer shell, it now has 8 electrons, making it stable like its nearest noble gas. Its net charge is now overall +1, because I still have my 11 protons, but now I have 10 electrons, because 1 went away, I subtracted 2, overall charge of +1. So now I have ionic sodium. Now, just like I can have elements that lose electrons to gain a full outer shell, the opposite can also happen to a set of different elements on the periodic table, which is basically my nonmetals. And they gain electrons to get a full outer shell, and these would be negatively charged ions. And they're negatively charged ions because I'm gaining electrons. And remember, electrons have a negative charge. So the more negative charges I accumulate, the more overall I become negative. And this happens to elements in groups 5, 6, and 7. So again, predominantly nonmetals. They form negative ions. So we're going to see an example of that. So if we look at chlorine, neutral chlorine would have 17 protons and 17 electrons. 2 electrons on the first shell, 8 on the second shell, and 7 on the third. Now, chlorine wants to obtain the same electron configuration of its nearest noble gas, which in this case would be argon. And argon has 8 electrons on its last shell. So that means chlorine needs 1 more electron. So it needs to add an electron to get a full outer shell, so it has the same configuration like argon. So if we add an electron to fill it in, well, now I have that configuration like argon. My full shell is full, so now chlorine is stable. And my net charge would be -1 because I have 17 protons. That hasn't changed. But now I have 18 electrons. And when I do 17 minus 18, my net charge becomes -1. So this would be ionic chlorine. So now, where did this mysterious electron that chlorine got came from? And on the flip side, where did sodium's electron go? So again, if I have sodium and I have chlorine, and if we're looking at it, remember, the electron from sodium, I have 1 electron too many because I want to get rid of this electron to have a full outer shell. Chlorine needs an electron to get a full outer shell. So the electron from sodium goes to chlorine. And this is how we form molecules. So our result is table salt. So that's basically the whole purpose of why ions are formed, for the production of molecules. So molecules form when our atoms rearrange their valence electrons to get full last shells. So like how sodium had 1 electron too many, chlorine needed an electron, so we had an exchange of electrons that sodium lost its electron, chlorine gained an electron, but then they both end up having full valence shells. So if we have another example right here with lithium and oxygen, we see that lithium has this 1 electron on its last shell that it wants to give away. Because if it gives it away, this shell disappears and it has a full valence shell of 2 electrons. So it goes to oxygen. But if we notice, oxygen still has an empty spot for another electron. So another lithium atom comes into play to give away its missing electron. So now we have oxygen that has a full last shell, and we now have lithiums that both have full last shells. So our end result is our molecule of lithium oxide. So I hope this helps explain a little bit how ions are formed, and I hope you have a great day.